Hello everyone, welcome to Chemistry Stars. In this video, I'm briefly going to discuss about the topic 18 electron rule, which is there in the chapter Organometallics. And also let's practice one or two previous year questions from this topic of CSA NET exam. Okay. So 18 electron rule simply states that thermodynamically stable transition metal organometallic compounds are formed when sum of d electrons and the electrons supplied by the surrounding ligands equal to 18. That is, a stable organometallic compound with transition metal is formed. That is, it is a complex and it is formed when the sum of the d electrons, that is valence shell d electrons of the metal and the electrons supplied by the surrounding ligands, okay, around that metal ligands are present, so the electrons supplied by that ligand should be equal to 18. So that is the condition for an organometallic compound to obey 18 electron rule. So why we are calculating this, we are looking whether a complex obey 18 electron rule or not? It is in order to predict whether the complex will be stable. So we can predict the stability of the complex according to 18 electron rule. So if it obeys 18 electron rule, it is stable. We can say that it has a stable configuration, so it is stable. And also whether there will be metal bonds present or not. We can predict whether in the structure of that particular complex whether there is a metal bond or not. We can predict that thing also. So for all these purposes, in order to understand the structure, stability and all these 18 electron will form the basis. Okay. In general, there are two methods of electron counting. That is, when you are provided with the organometallic complex, you can count the number of electrons by two methods. That is, one is neutral atom counting method and the next one is oxidation state counting method. In neutral atom counting method, see, both of these methods provide same result, and what is the difference is that in neutral atom counting method, we are considering the metal as a neutral atom. Metal is considered as a neutral atom, and according to that you have to take the number of electrons. And you also have to here you also have to count the number of electrons donated by the surrounding ligands to this neutral metal atom. So the ligand electrons are also counted. Okay, ligand electrons are also counted. And then if there is any charge present on the complex, you have to count the charge also. And what is oxidation state counting method? It is just opposite to that of neutral atom method. Here you have to calculate the oxidation state of the metal, central metal. And so here metal oxidation state is taken. Metal oxidation state is taken. Fine. We are not considering metal as a neutral atom in the oxidation state counting method. So also you have to take ligand electrons. Okay, you have to take ligand electrons. And see, if you are taking this metal oxidation state, there is no need to take no need to count the charge. No need to take the charge on the species. So these are the two differences between these two methods, and while when we move to these examples, it will be more clear to you. Okay, so let's practice some examples. The first example, first complex I'm taking is MnCO5-, which is a carbonyl complex of manganese metal. So we are going to count we are going to check whether this compound obeys 18 electron rule by counting the electron using both these methods. Okay, so first one is neutral atom method. So I'm considering metal as the neutral atom. So manganese is considered as the neutral atom here. So what is the valence shell electronic configuration in manganese? It is in the, that is number of electrons around manganese. It has, manganese has D5 configuration. So D5, that is 3D5 4S2. In the neutral state, it is 3D5 4S2. So there are total 7 valence electrons. 7 plus number of electrons donated by carbonyl ligand is by a carbonyl ligand is 2. So here there are 5 carbonyl 5 CO. So you will get 5 into 2, that is 10. And there is charge. In the neutral atom method you have to count the charge. So there is a minus charge. So you will get plus 1. Total it is 18 electrons. Now in oxidation state method you are going to consider Mn in its oxidation state. So here the oxidation state of Mn is, say, X minus 0 is equal to minus 1. So X is equal to minus 1. So the oxidation state of manganese in this complex is minus 1. Manganese is in a minus 1 oxidation state. So there are, see, in the neutral atom there are 7 electrons around manganese. So minus 1 means again you have to add an electron. 7 plus 1, that is 8 electron, and 10 electron from this carbonyl ligand. And you don't know, here in oxidation state method you don't consider the charge, because we have already considered the charge while calculating the oxidation state of the metal. So don't take the charge in oxidation state method. So here 8 plus 10, that is 18 electrons. So we can say that this particular complex of manganese obeys 18 electron rule and it is said to be stable. Now the next complex is HMnCO5. Okay, actually this is a hydride complex, right? Hydrogen is present in the form of hydride ion. So it is hydride ligand, okay, not ion, it is hydride ligand, it is also present. So you have to consider that particular heteroatoms also while counting the number of electrons, right? So in the neutral atom method, the number of electrons contributed by manganese is 7, and number of electrons contributed by hydride ion, okay, hydride ion is 1 and 1 electron. And number of electrons contributed by carbonyl ligand is 5 carbonyl ligands is 5 into 2, that is 10 electrons. So total there are 18 electrons. Fine. And in oxidation state methods, you consider the ox1 is actually minus 1 plus x plus 0 is equal to 0, and x is equal to plus 1. So here manganese is in plus 1 oxidation state, and so the number of electrons contributed by Mn plus ion is see, it is 7 for neutral atom, 7. So plus means an electron is lost, right? So 7 minus 1, that is 6 electrons. And hydrogen. Now let's practice a question which was asked in previous year CSIR NET exam. It is, the question is, choose the isoelectronic pair among following. So isoelectronic pair means the two compounds having same number of electrons, right? So the first complex is VCO6. So vanadium belongs to 5th group, that is configuration is 3D3 4s2. So here we are considering neutral atom method, okay. So vanadium 5 plus CO6. So 2 into 6, that is 12. So here 12 plus 5, that is 17 electrons. The second complex given is Cu eta 5 C5H5 CO. Copper 11 electrons, right? 3D9 4s2, so 11 electrons. And this is C5H5 is the pentahaptoligand, right? So pentahaptoligand contributes 5 electrons. So plus 5 plus from 1 CO is 2 electron. So this is total number of electrons here is 11, that is 18 electrons, right? 11 plus 7, that is 18 electrons. Now third option is CO. This is a carbonyl complex of cobalt, COCO4 minus. So here cobalt you have 9 electrons plus 4 into 2 8 electrons. You have to consider the charge. Minus means this plus 1. This is equal to 9 plus 9, that is 18 electrons. Now the last complex is the complex of iridium, IR, Cl, CO, PPH3 twice. In which group IR belongs? See, cobalt, rhodium, iridium. So it is ninth group, right? So iridium contributes 9 plus chloridoligan contributes 1 electron. CO contributes 2 electrons, and this is triphenyl phosphate ligand, right? One triphenyl phosphate ligand contributes 2 electrons. So here you have 2 into 2, that is 4 electrons. So it is 6 plus 1, 7, and this is 7 plus 9, that is here 16 electrons, right? So total, see here you will get the option as, see, this is also B option is 18 electrons and C option is 18 electrons. So the correct option is B and C. 4 options are given to you and the correct one is B and C because both these complexes obeys 18. Now let's practice another question. This is also a PYQ of CSIR NET exam and you can score easily from such questions. Okay, so this topic is very important and also you can score very easily from such questions. So practice more examples. Fine. The question is identify the species that obey 18 electron rule. The first complex is, see here, this is C5H5 ligand. It is a pentahaptoligand, right? So 5. This pentahaptoligand contributes 5 electron and copper means 11 electrons. That is 3d9 forest is the outermost electronic configuration. So it contributes 11 electrons and from one CO you will get 2 electrons. So 11 plus 2 plus 5, that is 18 electrons. Now from this, here you have 5 plus manganese contributes 7 electrons plus 2 electrons from 2 ligands, so 4 electrons, and here 5 plus 4 plus 7, that is 16 electrons. Now let's look another option, the other option. Here 5 plus chromium. Chromium belongs to 6 group, so you will get 6 plus 3 into 2, 6. 12 plus 5, that is 17 electrons. Here 5 plus vanadium. Vanadium belongs to 5th group. So 5 plus 5 plus 2 electrons from 4 CO. So 2 into 4, that is 8, and 10 plus 8, 18 electrons. So there is an, this is also A, option A is also obeying 18 electrons, or this D is also obeying 18 electrons. So there is an option A and D, and this is the correct option. Okay, because both these complexes are obeying 18 electrons. Fine. See, in this video I have only mentioned about this topic in a brief manner. You can boost your concept thoroughly and practice more examples by referring textbooks. See, there are so many examples, like in some complexes you can see questions like that. In some complexes there is metal bond present, so you have to count the number of electrons contributed by that metal bond. You can see such questions. And also if you are given a complex which obeys 18 electron rule, and you can predict structure and bonding of that particular complex by using that concept of 18 electron rule. You can see many such examples, many such questions. So you can practice these questions by referring reference textbooks. And for the reference, you can use, this is in organic chemistry, right? Organometallics. So you can refer in organic chemistry by Hui. It is a nice text, and you can boost your concept easily by reading that textbook in organic chemistry by Hui. And also there are many textbooks of Indian authors too, like B.D. Gupta, and there is a textbook Organometallics and Bio Inorganic by Ajay Kumar. You can refer that textbook also. Why Indian authors means the language will be more clear to you when you read books of Indian authors. So you can practice more examples, more questions, and you can read these books also, okay, in order to boost your concept. So that's all for today's video. Thank you and have a nice day.